Hello, everybody. Mr. Rubo here, and we are looking at questions 5 and 6 on the Chapter 2 review. So, question 5, we have this piecewise function. It's made up of two linear equations, and the domain of each part is listed right next to the equation. So, here for the first one, we want to know, is this point on the graph? So we could totally graph these both. There isn't really a spot to graph them on here, so we don't have to. What you want to look at is our x value. So our x is -8. So that's where you're going to look at this stuff on the right and determine, okay, which one of these situations would -8 belong to. So when you think about it, okay, if x is less than -4, we use the first equation. And then if x is between -4 and 10, we use the second equation. Well, x here is -8, which is definitely less than -4, which means I substitute it in to the first equation. Okay, so you do not substitute it into both. You only substitute it into the one equation that has that x included in it. So now if I do this, half of 8 is 4. 4 plus 3 is 7. So the coordinate point would actually be -8 comma 7, which is not -31. So the answer is no. Okay. So then the next thing is the domain. Now, with the equations we're going to give you for piecewise, like normally, -1/2 x plus 3 has a domain of all reals. 3x minus 7 also has a domain of all reals, but we're basically stopping each graph. So if you need to, you can graph them if you wanted to. Or you can just look at these and kind of put them together. So the first one, if we wrote it as interval notation, would be -infinity to -4, not included. But then the second one would be from -4 inclusive, so square bracket, and then to 10 and not including 10. So that's the two intervals that we actually graph the two functions on. But now we're putting them together because we're looking at the graph completely, which means we're going from -infinity. It's definitely our lowest. And then we have a break at -4, but then -4 is included in this one. So because of that, we can just jump right to 10. And it was a parenthesis for 10, so it's a parenthesis for 10 here. Okay, so that's one way of doing it. Again, another way is graph it and look off the graph. Okay, and then the last one for part C here is g of 20. So hopefully you may notice something. I just said our domain goes up to 10. If you are trying to substitute something that is outside of your domain, you get no solution or undefined, no answer, right? There's lots of different ways of writing this, but because 20 is not in our domain, which we just wrote, we get no solution. Okay, so now moving on to number 6. We have this function has a bunch of just these 3 ordered pairs, and we want to transform them based off what's written. So the first one, we have just a -4 multiplied by our function. So that means it's a vertical stretch and a reflection. But you can even read this. This is saying -4 times f of x. F of x is y. So really, we just take -4 and multiply it by the y's. So technically, if I'm being super proper, it would look like this. So 5 times -4 is -20. 7 times -4 is -28. And -10 times -4 is +40. So there is our answer there. You'll notice the x's stayed the same, but our y values were all multiplied by -4. All right, the next one is now the transformation is x plus 5. So f of x plus 5. Whenever you see x plus 5, it's talking horizontal shift, and it would be to the left 5. So if you take all of your coordinate points and you move them left, and we're talking the original coordinate points again. If you take all your original coordinate points and you move them left 5, that means you would take your x value and subtract 5. And the y coordinate would stay the same. All right. And as long as I can do my subtraction correctly, those are our coordinate points. So -6, 5, -5, 7, and -3, -10, because I've taken them all and subtracted 5. Okay. And then this last one for C, you can skip that one. I'll show you how to do it, but this is not, and the reason why I'm telling you to skip it is because of this ×2 on the inside. Yeah, it's not one we test on, so it's not one you have to worry about. But if you'd like to know how to do it, just like how with x plus 5, we ended up subtracting 5. Here we're doing -2 times x. So we do the inverse. So for our x values, we will actually divide by -2. So we get 1/2. I'm going to leave the y alone because we'll do something with that. We get 0. And we get -1. Now you'll notice I didn't put the y's because the y's we can, like, y's are nice in this one, the transformation y's at least. You just subtract 3, which means down 3. So you take all of your y's and subtract 3 from them. But again, this one you could totally skip as well. It is not necessary to know, for our test at least. Okay, well, thanks for watching, and the next video will have number 7.